All right, same thing. So I want you to do it first. Don't just look at the answer. Okay, so I want you to think first, and then you check with me and see what went wrong, or you maybe your thinking process is not the right direction. All right. So the solubility product of barium sulfate is really low, 10 to the negative 10th. If barium sulfate dissolved in pure water, what is the concentration of barium ions? All right. So first off, write the dissociation equilibrium first. So barium sulfate, solid, not soluble, dissociate into barium ion and sulfate ion, 1-to-1 ratio. Okay. Ksp can be expressed as the concentration of the product times concentration product. That's it. All right. So we want to find the concentration of barium ion. All right. So we know Ksp, but we don't know sulfate ion. Well, what we do? Well, here's the thing though. In this case, this is kind of a math thing. So I want to show you right here. So let's say if barium sulfate, just assume, just imagination, barium sulfate dissociate in water, so dissolve in water 100%. If I have a 1 molar of barium sulfate, what is the concentration of barium ion? Let's say if barium sulfate dissociate 100%, this dissolve real well in water, just like sodium chloride. Okay. If I have 1 molar of barium sulfate solution, what is the concentration of barium ion in this solution? 1 molar, so 1-to-1, right? What about the concentration of sulfate ion? Also 1 molar. Okay. So, but in reality, this guy is not dissociated in water, so not soluble in water. But my point is, if this were to dissociate to give the some concentration of barium ion, which is really small, and also some concentration of sulfate ion, the concentration of these two species are exactly the same. It's 1-to-1 ratio. Does it make sense? All right, so it's 1-to-1 ratio. So you have concentration of barium ion equal to sulfate ion, which means that these two right here are the same value. So I can just do x squared on the right side. Yeah, they are the same value anyway. All right, to solve this, just take square root on both sides. The answer you should get is 1.04 times 10 to the negative 5th. So the concentration of barium and sulfate are exactly the same. Okay, so there's a little trick right here. That's why I want to show you. All right, one more time. So this is also a little trick here. Solubility product of silver chloride is really small, 10 to the negative 11, even worse than barium sulfate. If silver chloride is dissolved in pure water, so the dissociation constant right here, what is the concentration of silver ions in molarity and in ppm? The top number. Okay, all right. All right, so Ksp can be expressed as concentration of silver ion times concentration of chloride ion. Look like that. All right. And the Ksp is that number, so right there. So we want to know the concentration of silver ion. That's what we want to find, silver ion. All right. So, well, if silver chloride were to dissociate to silver ion and chloride ion, they have the same concentration. It's 1-to-1 ratio. So these two are the same concentration, right? So we do x squared, and then same thing, you square root on both sides. You should get that number, all right? So the concentration of silver ion and chloride ion still the same number, that number. All right. Now that's the molarity. So we got molarity there. Well, so the question asks for ppm, right? So the concentration of silver ion in ppm. But if you write just ppm like that, you're not gonna get that unit. No way you're gonna get to like just ppm like that. You have to go to the definition of it. ppm is part per million, right? So we go 1 gram of silver ion per 10 to the 6 gram of solution. Okay. So right now we have 4.21 times 10 to the negative 6 mole of silver ion per 1 liter or 1,000 milliliter solution. Like do like that. All you have to do, convert mole silver to gram silver ion. See that? And milliliter solution to gram solution. That's all you have to do. All right, start with mole to gram. So use molar mass, put moles at the bottom, grams at the top. Mole cancel out. You got this step. All right. Now, milliliter to gram. What is it? This is volume. This is mass. A totally different unit there. But they're related by the density. All right. So density is the only quantity that relates mass and volume. And again, this solution is really, really dilute, 10 to the negative 6, really dilute. So the solution is to act just like water, same property with water. So density is 1. So I can change from milliliter to gram. Just it's 1-to-1 ratio. Right? Density of water is 1 gram per milliliter. So right here. So milliliter cancel with milliliters to gram now. Now, last thing I have to do. So the unit that I want is 1 gram. So gram of silver ion per 10 to the 6 gram of solution, right? So at the bottom right now, I have 1,000 and gram solution already. All I need to get to 10 to the 6 gram solution is times 1,000 at the bottom. And if I times 1,000 at the bottom, I have to do it at the top too. So I can't change the value in here. So this is the whole term is 1, all right? So right now I have 1,000 times gram per solution. So I'm going to have 10 to the 6 gram solution at the top, and at the bottom, at the bottom. And at the top, you just do calculator right there. 1,000 times 107.87 times 4.21 times 10 to the negative 6, you get that grams of silver ion. And take a look here, gram silver ion and over 10 to the 6 gram solution, that is ppm. Yeah, that's it, and 3 sig figs. All right, so you have to practice it. So class activity number 4, and see me on the next video.